Okay, so let's go ahead and find the exact value of something like this, where you're given one of the trig ratio, and we're going to find the remaining 5 based on what is given. Now, keep in mind that you're not given value for theta. You're given a trig ratio of theta, and you're given which quadrant theta is located. So for something like this, you will want to draw a picture. So suppose this is our XY plane, and theta is in quadrant 3. So theta will be right here. So if I draw a right triangle in this quadrant, so here's our right triangle, it would be something like this. And theta is coming up from here. So that's theta, and this is our right angle. Now let's go ahead and label the sides. So we know across from theta is opposite. That will make this the adjacent side, and this is the hypotenuse. Now we're given tangent of theta. So tangent theta is equal to 12 over 5. Well, we know tangent is opposite over adjacent. So that means our opposite side is 12, our adjacent side is 5. Now, we also have to be careful that because we're in the third quadrant, sometimes the x could be negative or y could be negative. In this case, they're actually both negative because this is negative x direction, this is negative y direction. So therefore, I'm going to label this negative 12 and negative 5. Okay, so now let's figure out the hypotenuse. Well, for that, we're going to use the Pythagoreans theorem. So we know that for a right triangle, a squared plus b squared is equal to c squared. That's for the right triangle. So c is the hypotenuse, and that's what we're looking for. So let's call that question mark square. And a and b could be either negative 12 or negative 5. So this is, let's say this negative 12 square plus negative 5 square. And then we get 144 plus 25 is equal to question mark square. And then if you add them up, we get 169, which is equal to question mark square. And finally, question mark will be 13. So there you have it. So the question mark we have here is going to be the side 13. And that's always positive. Now let's find the remaining trig ratios. So once you complete the triangle, the entire, all the sides, then you can freely write down the remaining trig ratios. So we know by definition, sine of theta is opposite over hypotenuse. So in our case, our opposite is negative 12, and our hypotenuse is 13. So that will be the exact value for sine. Now, what about cosine? Well, cosine of theta is equal to adjacent over hypotenuse. So therefore, adjacent is negative 5 and hypotenuse is 13. So that's the exact value for cosine. Now, tangent we're already given. Now let's go ahead and find the reciprocal functions. So cosecant theta, that's the reciprocal of sine. So this is 1 over sine theta. So you can use the picture if you want, or you can just reciprocate the value for sine you just found. I will do that. So I have 1 over sine, which is negative 12 over 13. And that simplifies to negative 13 over 12. That's the reciprocal of sine. And then cosine, the reciprocal is secant theta. So that's 1 over cosine theta. And if you reciprocate that, you get negative 13 over 5. And finally, we have one more trig ratio left, which is cotangent of theta. And that's the reciprocal of tangent. So we get 1 over the value of tangent. And tangent was given to us, so that was 12 over 5. So we know that's going to be 5 over 12. So there you have the remaining 5 trig ratio based on the picture. So if you have something like this, you draw a right triangle, and determine the missing length. And from there, by definition, you can write down the remaining trig ratios. Okay, so I hope you enjoyed this.